Hello everyone, and welcome back to another GIS Mathematics tutorial lecture video. And in this lecture video, I want to go through an example of how we can use those relationships we talked about in the previous video that relate radius, the angle in radians, and the arc length along the outside of the circle to each other. And I want to use that to solve for arc length in a particular example. So in this example, right, find the arc length, right? So we're going to circle the arc length, right? We're finding the arc length given an angle of 50 degrees. We're going to need that information as well. And a radius of 10 centimeters. Okay? So the first thing I want to do is I want to recap those relationships that we talked about before. So let's assume that we have a circle here with a center. Right? And we have from the center of the circle, right? Anywhere we go, once we hit the circle, we've created a radius, right, of r. We know that if we go along the circle some distance, right? This is an arc, and we're going to call that distance s. That if we connect it with a second radius like that we get some angle. Some angle is created that subtends. Again, it's inside of the circle that subtends this arc. And we call this angle theta. All right, and we generated that relationship of S over R equals theta, where S was the arc length, R was the radius, and theta was the measure of the angle in radians. Right, in radians. So let's take a look at our problem. Find the arc length. Okay, well, we need to isolate arc length. That's pretty easy. Right, we just manipulate this equation to get arc length on its own. We multiply both sides by r. So this is going to be S is equal to theta times r. So right, it's the angle in radians times the radius of the circle. Pretty straightforward. Given the angle of 50 degrees, well, this theta here needs to be in radians. So the first thing we're going to have to do before we go any further is convert from degrees to radians. So let's do that really quickly. So we have x rad, or x radians, is equal to 50 degrees. Right? That proportion is the same proportion as 2 pi radians over 360 degrees. Right? This is the same conversion process we went through in previous videos. So if this seems confusing, I encourage you to go back and watch those examples again. Right, so we can do some quick math here, right? We can do 50 times 2 is 100 pi over 360. I'm dropping the units now because it's just convenient. Right, 100 divided by 360 is 10 over 36 pi. And that's going to be equal to 5 over 18 pi. Right, I've just been reducing this fraction down. So 5 over 18 pi. This is 50 degrees in radians. So now we can plug this back into the equation here. So we have S equals 5 pi over 18 times 10, right? Radius is 10 centimeters. So that's going to be 50 pi over 18. Right, now we can divide that by 2 to get 25 over 9 pi radians. So now what we could do is we could leave it like this, but what you're going to want to do is you're going to want to actually do the math to figure it out. All right, so if you do the math, 25 times pi divided by 9, you're going to get approximately 8.73. Go back to the original problem. That's in centimeters. All right, so that is the answer to this question. 8.73 centimeters. Hopefully that made sense. Hopefully you followed the logic here. If you have any questions, please go back, watch the part you're confused about, and as always, please reach out. Thank you.